Hello student, welcome back to lecture series on numerical methods for numerical solution for ordinary differential equation. Okay, so already I have explained plenty of the videos guys based on these topics. In my last lecture I explained here the Runge Kutta method for the second order. Okay, so in our today's video guys I'm gonna explain to you all one of the example based on the Runge Kutta method for second order. If you're interested to see similar method or last method for Runge Kutta method, okay, detailed understanding of Runge Kutta method, go and check in my I button over here, or you can see in my description box. You will get the complete playlist. Okay, so without further ado, let's get into our today's lecture guys. This is one of the important example, similar type of the example you will get it in your question paper. Okay, yes, now let me read the question. Use Runge Kutta formula of a second order to find out the value of y when x is a 0.1 and x is a 0.2, given that dy by dx is equal to x plus y with y of 0 which is equal to 1. Okay, yes, that means we have to find out the Runge Kutta formula for second order. As we have given x as a 0.1 and a 0.2, so that we have to take the two different iteration for the value of y. Okay, like y1 and y2 we have to find it out here. Okay, yes, now let me recall Runge Kutta method. Okay, for second order and second order for y1 and y2 values. Okay, so it is one of the easy guys. Okay, so we know that Runge Kutta method for second order, we write y1, okay, y1 which is equal to y naught plus y1 is equal to y naught plus 1/2 k1 plus k2. Okay, y1 which is equal to y naught plus 1/2 k1 plus k2. Okay, yes, now see that we want the two different iteration. That means we have to apply similar formula one more time with the values which are coming from here. We have to take it to the another formula. Okay, so what is the value for k1? Okay, so we know that the k1 is a h of x naught comma y naught. Okay, we consider it is the h of naught. Okay, that means h of x naught y naught as a k1. Okay, similarly k2, the value for k2, we know that the value for k2 which can be written as h under bracket f of x naught plus h, f of x naught plus h comma, okay, y naught plus k1, y naught plus k1. This is under bracket. Okay, and bracket complete. This one is the value for k1, this one is the value for k2. Okay, so we have the two value y of 0.1 and y of 0.2. that means we have to use this formula for the two different values. Okay, so let me write the another value also. Okay, so this one is applicable for 0.1. so if you want the for the 0.2, so you can take coming value from here to the another this formula, you will get the another value. Okay, so let me write this one as a y2 which is equal to y1. Instead of y1 not, you take y1 plus 1/2. Instead of k1 k2, consider it as the value which is coming from here. Now you have to take it here. Okay, for this formula. Okay, then consider k3 k4. Okay, you can consider k3 k4. Okay, or you can take it k1 k2, but the value for x naught y naught, these are going to change. Okay, so how can we write k3 h as it is under bracket f of x1 comma y1. Okay, bracket complete. Okay, this one is for k1 k3. Okay, so if you want the value for k4, so k4 we are going to write h under bracket f of x naught plus h. Take instead of x naught plus h, take it as the x1 plus h. Okay, so f of x1 plus h comma y naught plus k1. Okay, y naught plus k1, instead of that we are going to write another values. Okay, instead of k1 we have taken k3. Okay, so we are going to write y1 plus k3. Okay, y1 plus k3. So this is quite a bit confusing to understand these formulas guys. Okay, so I will suggest you all guys, just for few minutes ignore these formulas. Okay, ignore that second formula, remember first one only. Okay, let me find out the iteration here for using our first formula, then I will explain to you all that second one. That one is easier to understand later on. Okay, first of all we have to focus on this formula only. Okay, Yes, so for this formula we need some different values. Okay, first of all, find out the value of f of xy, then x naught y naught, again the value for h and everything here. Okay, yes. So now see that we don't have given h over here, so we are going to consider h as the 0.1 here. Okay, we are going to consider h as a 0.1. so first we are finding for x is a 0.1. okay, x is a 0.1. we are finding for x is a 0.1. using this one we are going to apply here. Okay, x is a 0.1. okay, that means f of x which is equal to y, so we are taking y of 0.1. that means we are finding y of 0.1 over here. Okay, we are finding the value for y of 0.1. so y of 0.1 means we are taking, using y of 0.1 we take h as a 0.1, as we don't have given h. so the value which we are using for finding our absolute k1 k2 and first iteration, we consider it as the absolute difference. Okay, so y of 0.1 we consider h as a 0.1 here. Okay, so we got the h as a 0.1. so after that dy by dx is x plus y given. Okay, so dy by dx we have given x plus y, and we know that dy by dx we write it as the f of xy. Okay, dy by dx as the f of xy. Okay, so then we write f of xy as x plus y. f of x comma y we write x plus y. Okay, we write f of x comma y as a x plus y over here. Okay, so we got the f of xy as x plus y. now let's go for finding the value for k1. Okay, so k1 we know that what is the k1, h times f of x naught comma y naught. Okay, yes, so we know that the value for h, now it is we have task to find out the value for x naught y naught. Okay, that means this implies f of xy can be written as f of x naught and y naught comma f of x naught comma y naught, we write x naught plus y naught. Okay, yes, f of x naught comma y naught we write f of x naught y naught as x naught plus y naught. Okay, yes, now see that x naught y naught, these are the initial boundary condition that we can write from y of 0 which is equal to 1. Okay, so we know that y we have given y of 0 which is equal to 1. Okay, that means y of x naught which is equal to y naught. Okay, compare both of these values here, so we get the x naught 0, this implies x naught which is equal to 0 and y naught which is equal to 1. Okay, these are the two value we got it here. Okay, x naught 0 and y naught 1. so replace this value here, instead of x naught y naught. Okay, 0 plus 1. Okay, so we got the f of x naught y naught as a 1 over here. Okay, so replace this value in our k1. so we are going to write k1 as, what is the value for h is a 0.1. okay, h is a 0.1 multiplied by f of x naught y naught, it is 1. Okay, so I got the value for k1, I got the value for k1 as a 0.1. I hope you all have understood how I have written the value for k1 is a 0.1. Okay, yes, again we are going for the value of k2. Okay, so we are going for the value of k2. so what is the formula for k2? let me write the value formula for k2 now. h times and f of x naught plus h comma y naught plus k1. Okay, this one is the value for k2. Okay, so let's replace the value over here. Okay, so what is the value for now see that y naught plus k1. Okay, so you have to take k1 from here. Okay, yes, what is the value for h we have here 0.1. Okay, let's replace this value 0.1. I took h as a 0.1, f of multiplied by f of x naught plus h. Okay, so what is the value for x naught? X naught is a 0, 0 plus 0.1, 0 plus 0.1. Okay, 0 plus x naught plus h, 0 plus 0.1 comma y naught plus k1, y naught 1 plus k1. what is the value for k1 is a 0.1. okay, this one is complete. Okay, this is the entire value for k2. Okay, so f of then let's go for the next more step. 0.1 multiplied by f of 0.1 comma 1.1. okay, 1.1. So we have f of xy as a x plus y, then f of 0.1 plus 1.1. Okay, f of x comma y, we know that x plus y, then we write f of 0.1 comma 1.1, we write 0.1 plus 1.1. Okay, we write 0.1 plus 1.1. Okay, that means we write 1.2. Okay, 1.2 here. So 1.2, this is the 1.2, we multiply it to the 1.1. Okay, so 0.1 multiplied by 1.2. Okay, this one is the value for k2 that we are working. Okay, so multiply both of them. Okay, so you will get the 0.12. So we write k2 as a 0.12. Okay, these are the two value we received here, k1 and k2, 0.12. Okay, yes. So replace this k1 and k2 in our y1, then you will get the first iteration. Okay, so we have y1 here, we write y1 which is equal to y0 plus 1/2 k1 plus k2. Okay, this one is our first iteration. Okay, so what is the value for y0? Y0 is 1. Okay, 1 plus 1/2 under bracket k1 plus k2. Okay, 0.1 plus 0.12, 0.1 plus 0.12. Okay, yes, 0.1 plus 0.12. So add all of these terms. Okay, use your calci. So we'll get the 1.11 as our y1. So I got the y1 as 1.11. Remember guys, this one is our only the first iteration. Okay, this one is our only the first iteration, as we have given in our example. For x is a 0.1 and x is a 0.2. Okay, so we have x is a 0.1 and x is a 0.2. So we have to find out the value with respect to 0.1 and with respect to 0.2. So I got the value with respect to 0.1. Now I'm going to consider x as a 0.2, that means y of 0.2. So let's determine the value for y of 0.2 over here. Okay, yes. Okay, to determine, let's go for the finding the value. To determine x as a 0.2. Okay, that is determine for the value of x as a 0.2, that is y of 0.2. Okay, y of 0.2. So we know that the value for h we are going to consider 0.1. Absolute difference, it will remain same everywhere. Okay, h as a 0.1. Okay, so for our next formulas. Okay, so see that these values we needed here, y1, k3, k4. Okay, all these values we needed over here. Okay, so it is not that difficult guys, it is way easier. Okay, the value which we received from here, k1, k2, y1, that you have to replace here. Okay, that all values you have to replace. If you are confused about these values guys, so you can keep this one in mind only. Okay, so if you are confused about this to create the values. Okay, so I feel that this one is quite confusing. Don't go for these values. I'm going to explain here with these values only. Okay, yes, but now you have to make sure that the values which are coming here, okay, which we received after this calculation, that we have to take it here. Okay, as our basic values. Okay, so now see that how I'm going to take the value. Carefully watch here, it's not that difficult guys. Okay, it is one of the easier. Now see that I written all these values over here. Okay, now see that we want the value to replace over here with respect to x as a 0.2. Okay, for our second iteration. So if I'm going to consider y2, y3, some another variable, maybe it will be the confusing. Okay, so it is better to keep our Runge Kutta second order formula as it is. Don't do anything changes. Okay, the value which we want here, y0, y1, k1, k2, f of x0, y0, x0 h, y0 k1, all are going to change. Okay, so how they are going to change, now see that. First thing, that h is our absolute difference, it will remain same. We cannot change that, the h over here. Okay, we are finding the value with respect to x as a 0.2, that means we are finding the value of y of 0.2. Okay, yes. Now see that this one is a second iteration. Okay, this one is a second iteration, so we have to consider basically here as a x1. So if you're going to consider x1, you have to take x1 here. but instead of taking x1, I consider x0 as it is, so that we don't have to change the formula. Okay, yes. So x0 I have considered as a x0 plus h, because it is behave as a x1. This one behave as a x1, but we don't have x1 here in our formula. Okay, so that for our second iteration, I'm adding x0 for x0 plus h. Okay, so x0 plus h I consider as a x0 for our second iteration. Okay, so that you can replace for here value here. Okay, we don't have x0 as a 0 here. Okay, we don't have x0 as a 0 because this one is our second iteration, so we write second iteration as a x0 plus h. Okay, so for that x0 I consider x0. Okay, so 0 plus h, 0 plus h, 0 plus 0.1, x0 is a 0.1. Okay, so next we want the y1. Okay, y1. Okay, so y1 means we want the value that to replace y0 over here, this y0. Okay, so see that this y0. Okay, this y0 I instead of see that this y0 I want here. Okay, so in our previous iteration, see that I got the y1 as a 1.11. Okay, y1 as a 1.11, but that one in our second iteration we supposed to call it as the y2. Okay, we supposed to call it as the for our second iteration as the y1, but if you're going to consider this y1, so I have to take as the y0 as y1, y1 as y2, so all the value are going to change here. This one is y1, this one is y1. Okay, so instead of changing the value that I received y1 here 1.11, I consider it as the y0, so that you can replace as only one iterations. Okay, yes, but this one is our second iteration, so y0 is equal to 1.11. Okay, I hope you all have understood h, x0, y0, how these values I have written over here. Okay, so that will be the helpful for finding the f of xy. So we know that the f of xy we have here. What is the value for f of xy? As a x plus y. Okay, f of xy as a x plus y. So f of x0, y0. If you want f of x0 comma y0, we write x0 plus y0. Okay, so what is the value for x0? 0.1, y0 is 1.11. Okay, 0.1 plus 1.11. Okay, 0.1 plus 1.11. You can put this value here in our value of k1. So let's find out the value for k1 again for our second iteration. Okay, what is the value for h? It is 0.1. Absolute difference, it will remain same, guys, everywhere. It is not changing at any place. Okay, yes, h it is a 0.1. f of x0, y0 we have here 0.1 plus 1.11. I hope you all have understood how I have written this one, not the difficult, guys. Okay, h it is here, f of x0, y0 I replace here, x0, y0 it is here 0.1, 1.11. Okay, as per our previous iteration I got these values. Okay, yes, so k1 is equal to 0.1 multiplied by 0.1 plus 1.11. so use your calci, so you will get the value for k1. So you will get the value for k1 0.121. Okay, 121. So this one is the value for our k1. Okay, so similar do it for the k2. So k2 we know that h is a 0.1 as a k2. F of x0 plus h, y0 plus k1. Okay, so we want the f of x0 plus h and y0 plus k1. So let's put the value we are going to find multiplied by, here we need the f of x0 plus h, y0 plus k1. Okay, let me find the value here, f of x0 plus h comma y0 plus k1. Okay, so f of x0, what is the value for x0 here? 0.1. 0.1 plus h we have here 0.1 plus 0.1. Okay, yes, comma y0, what is the value for y0? We have here 1.11 plus k1, what is the k1? 0.121 plus 0.121, bracket complete. Okay, so f of xy as a x plus y. Okay, that means we add 0.1 plus 0.1, we write a 0.2. Okay, so we write f of 0.2 comma, we write f of 0.2 comma, and 1.11 plus 0.121. Okay, we write 1.231 bracket complete. Okay, so we write this one as 0.2 plus 1.231 as a 0.1431. 0.1431. We write see that after solving, okay, let me write this value. Let me write f of 0.2 plus 1.231. okay, f of xy is x plus y, that means add both of them. 0.2 plus 1.231, 1.231. okay, add both of them here, multiply this one. At the end eventually you will get the value k2 as a 0.1431. okay, 0.1431, 0.1431. this one is the actual value for k2. So I got the value for k1, I got the value for k2 over here. okay, k1 and k2. So we are finding the value of y2 now. okay, y2 means y of 0.2. we are working on the y of 0.2. okay, so we know that it can be written as y1, that means y0. okay, that means y0 plus 1 half k1 plus k2. so what is the y0? 1.11. okay, y0 plus 1 half k1 plus k2. let me write these values again. okay, yes, put the y0 here, 1.11. 1.11 plus 1 half under bracket k1. what is the value for k1? 0.121. 0.121 plus k2 0.1431. 0.1431. okay, this is the bracket complete. So after calculating all this value, you will get the y2 as, you will get the value for y2 as use the calci guys. First of all, add both of them, divide by 2 and then add 1.11. okay, so make sure that bracket need to be there, don't make any mistakes. okay, so 1.24 205. okay, this one is our value for y2. okay, this one is our required value for y2 that we want in our given solution. okay, and now see that this is our example. Use Runge Kutta method of a second order to find out the value of when x is 0.1, 0.2, given that dy by dx is x plus y, with y of 0 is equal to 1 as the initial condition. okay, yes, so using this one I applied the first second order Runge Kutta method. okay, second order Runge Kutta method, I by using our previous data I found the value for f of xy, x0, y0. then I got the value for k1, use the value for k2 and put it here in y1 is equal to y0 plus 1 of k1 plus k2. okay, for our second iteration y of 0.2, what we have to do, we have to take these values combined together. okay, this one k1, y1, k2, y2, everything for our second iteration. okay, that second iteration I define here. okay, to determine x as 0.2, I consider h, it is absolute difference, it will remain same everywhere. okay, yes, and about the values for x0, y1, you must have to take it from your previous iteration that you solved in your example. okay, don't consider these values from your given example. These are the values that you received from your last iteration. okay, yes, h, x0, y0 means I consider y1. okay, that I replace again in our Runge Kutta second order method. y1 is equal to y0 plus 1 of k1 plus k2. k1 is equal to h f of x0, y0, and k2 is equal to h f of x0 plus h, y0 plus k1. okay, so I found these values here, k1, k2, and f of x0 plus h, y0 plus k1. okay, and I replace these values in y0 plus 1 of k1 plus k2. And so at the end eventually I receive the answer y2 is equal to 1.24205. okay, that is our required final answer. I hope you all have understood guys my entire solution. Example is very much important for your ENDSEM exam guys. okay, so get it prepared, see this video again and again. Important video guys, more important videos I will upload in our channel. okay, so as the ENDSEM exam is coming guys, take it little seriously, not that difficult, but at least if you practice once this example, you will get the good result. okay, yes, I hope you all understood here my today's lecture guys. So thank you everyone, that's it for my today's lecture. Thank you all.